So I'm going to flip a coin, and I've got two possibilities, okay? Coin only has two sides. I can either get a head, or I can get a tail. The chance of me getting a head, as long as it's not a lopsided coin that's a cheat coin with different weights, a natural coin, it's a half a chance of me getting a head, and there's half a chance of me getting a tail. If I've done this right, these two probabilities on this level should always add up to be 1. Does a half and a half add up to be 1? Yes. Okay, so I've done it right. I'm now going to toss the coin again. What are my possibilities again? And we call building these probability trees, okay? They look a little bit tree-like. If I was to toss the coin a second time, if I got a head the first time around, I still only have two possibilities, a head or a tail. But I could have got a tail the first time around, so now I have the probability again of getting a head or a tail. What's the probability of me getting a head, first a head, and another head? Whenever I use the word and, I multiply. So the chance of me getting first one head and another head is a half times a half. Remember your rules of fractions, multiplying fractions. 1 times 1 is 1, 2 times 2 is 4. So the chance of me getting 2 heads is 1/4. What's the chance of me getting first a head and then a tail then? Well, it's the same thing. First chance was a half, that I got a head, and a tail. The chance of me getting a head and a tail is 1/4. The chance of me getting a tail here was a half after the head, but the chance of me getting first one head and another head, that's 1/4. So it's going to be 1/4 on all of these. Do you see? There's first a chance of a half, and then there's a chance of another half. So each of these factors here end up being 1/4. If I've done it right, 1/4 plus 1/4 plus 1/4 plus 1/4 will add up to be 1. It does. So now let's look at the chance of me going down this string. First I get a head, then I toss the coin again, I get another head, then I toss the coin again, I get another head. What's the chance of me getting a third head? Well, it would be a half times a half times a half. I need to get first a half and another half, multiply between, and another half, multiply between. A half times a half times a half has a chance of 1/8. If this has a chance of 1/8, I think you can see that all of them are going to have a chance of 1/8. Head, tail, head, tail, head, tail, head, tail. So all of these chances down here of me going first head, tail, head is 1/8. Head, tail, tail, it's a different one. It's 1/8. Tail, head, head, 1/8, 1/8, 1/8, 1/8. And we know that that is correct because if we add all of the 1/8s we've got 8 of them there, we're going to get a total of 1. So if I was to say, what's the chance of me getting one head? I'd look at the probability on the tree here. It's a half. What's the chance of me getting 2 heads? Well, I'd have to look. Second level of the tree, I'm not bothering about the third at all. I'd have to say, is there anywhere where I get head and head? Here I get a head and head, but here I don't. I go head, tail. Here I go tail, head. And here I go tail, tail. So there's only one probability of me getting head, tail, and it's this one. One time. And the chance of me getting that one is, I know, 1/4. So the chance of me getting 2 heads is 1/4. What's the chance of me getting 3 heads in a row then? Well, there's only one chance of getting 3 heads because all the other ones have a tail in somewhere. So the chance of me getting 3 heads is a half times a half times a half. It's 1/8. So when I make these factor trees, it's actually very easy to work out what's the chance of me getting 3 heads in a row. It's 1/8. What about if I'm not going to get 3 heads or 3 tails? There's two different ways of doing this, and I'll show you both of them. Well, one of them is, you know that the chance of getting 3 heads is 1/8. And you know that the chance of getting 3 tails, which is also the other extreme here, this is the only place we can get 3 tails, is also 1/8. Anything that isn't 3 heads or 3 tails is the mixture in between. So how would we get that? 2 ways. We can take away 1/8 and 1/8 from 1. Because we know that all these probabilities on this level end up adding up to give us 1. So we could take 2 lots of 1/8 is a quarter. 1 minus a quarter, it's 3/4. 1 minus a quarter is 3/4. So the chance of me getting neither 3 heads or 3 tails is 3/4. You can represent probability as a fraction, or as a decimal, or as a percentage. Fraction is the most common, but you can use either of them. How could we have done it if we didn't use this method of subtraction? Well, we could have looked at how many probabilities do I have of not getting all heads and all tails? Well, this is one probability. If we just follow the tree down here, here's one solution, so that would give me 1/8. Or I could have gone, and when I see the or sign, when I'm saying to myself I could do this or I could do this, I use the plus sign. So I could use this combination, or I could have gone this combination. That's another 1/8. Or, plus sign, I could have gone this way around. That's another 1/8. Or I could have gone this way around, another 1/8. Or I could have gone this way around, that's another 1/8. Or I could have gone this way around. That's another 1/8. And I could have added, have I missed one? No? 1, 2, 3, 4, 5, 6 eighths, giving me 6 eighths on neither all heads or tails. Simplify 6 eighths, don't leave it as a fraction. Both of these can be divided, top and bottom, by 2 into 3/4. So this is a new concept that's important to understand and work on and focus. Factor trees help a lot. And I'll give you another couple of examples of what we could do.